Hello friends, hope you're all doing well and welcome to Naurusa CSC tutorial. Hope you're all doing well. So on my last lecture, I discussed some of the important examples on POSET and hash diagram. And today, I'm going to start with maximal and minimal elements of a POSET. So let's see what are those. Let S be a POSET. An element B in S is called a maximal element if no other element of S strictly succeeds B. So what does it mean? There will be not any element who will succeed B, and like there will be no child of B. So those elements will be maximal element. A set or a POSET can have more than one maximal elements. Now consider this example for maximal element. Like here 18 and 24 has no child, or no, like any other element has not succeeded these two elements like 18 and 24. So these are the maximal elements of this POSET. Now minimal element. An element A in S is called a minimal element if no other element of S strictly precedes A. So any other element will not precede A, like there will be not any parent of A. Then A will be called as minimal element. Again, considering the same hash diagram for the minimal element, like we can see that 1 has not been preceded by any other element. So here 1 is the minimal element of this POSET. So this is the minimal element. And here are some of the notes to maximal and minimal elements. And those are: a POSET can have 2 or more minimal element and maximal element. A POSET may have no minimal or maximal element. If a POSET is finite, then it must have maximal and minimal elements. The POSET z less than equals to, where z is equal to set of all integers, has no minimal and maximal elements, cause z and less than equals to this POSET is not a finite POSET. So that is why it has no minimal or maximal elements. Now I am starting with greatest and least elements in a POSET. Let S and less than equals to be a POSET and A be a subset of S. An element A of A is called greatest element of A if x less than equals to A for all x in A. Let me take you to the example. Now if we consider this example, S consists of these elements be the POSET with respect to the relation divisibility. Its hash diagram is in the figure we have seen. Consider the subset A, where A is consist of 1, 2, 4, 6, 12. We can observe that here 12 is the greatest element, cause 1 will divide 12, 2 will divide 12, 4 will divide 12, 6 will divide 12, and 12 itself will divide 12. So 12 here is the greatest element, cause all other elements of the set will divide, like with respect to the divisibility relation, 12 in this set is the greatest element. And here 12 is also the maximal element of this POSET. On the other hand, we see 1 will divide all other elements. So here 1 is the least element and also the minimal element of this POSET. As from the definition of least element, we see an element b of a is called least element of a if b less than equals to x for all x in a. Again, if we consider the subset b consists of these elements, then we can see that b has no greatest element, cause here 18 will not be divided by all other elements. Like here 2 will divide 18 but 4 will not divide 18, and also there is 12, like all other elements will not divide 12, like 9 will not divide 12. So that is why this set has no greatest element, but 12 and 18 are maximal element here, cause if we draw the hash diagram of this POSET, then we can observe that 12 and no other element will succeed 12 and 18. So these two are the maximal elements of this POSET, but this set is not consist of any greatest element. And one is least element as well as minimal element of B, and B has no other minimal elements. And here are some of the notes. So every greatest or least element is a maximal or minimal element of a set, and the converse is not true. In fact, if a set has unique maximal or minimal element, then it is the greatest or least element of the set. So please subscribe, like and share my videos, and do comment if you have any query on my lectures. So for today, thank you.